Hello and good afternoon, everybody. Myself, Dr. Vivekanand Jadhav, Assistant Professor in Sri Muktanand College, Gangapur, in Department of Chemistry, Sri Muktanand College, Gangapur. Today, I'm going to discuss one of the most popular reaction in organic chemistry, and that is called as Grignard reagent. So Grignard reagent is one of the most popular reagent in the field of organic chemistry. And today we are going to learn some of the basic aspects regarding these Grignard's reagents. The name itself indicates that it is a reagent and it is invented by a famous scientist Grignard. So in the fond memory of this invention of this versatile reagent, the name its name has given as Grignard reagent. So what is Grignard reagent? Grignard reagent is nothing but it is the combination of any organic plus metal. That means it is this reagent is combination of any organic compound and one metal, and it is again aligned with some alkyl halide. That means this is Grignard reagent is an organometallic reagent that is attached with alkyl halides. Some of the prominent organometallic reagents used across the globe are alkyl magnesium halide, that is where R may be any alkyl halide, X may be any halide, dimethyl copper lithium, tetramethyl lead, and N-butyl lithium. All these examples falls under the category of Grignard reagents, and depending upon the metal that is involved, the different types of organometallic reagents are prepared. In this first category, RMgX is called as Grignard reagent, and it is generally named as alkyl magnesium halide. And in this R may be any alkyl aryl group, vinyl group, where X may be any halide, that is chloride, bromide, or iodide. And among these halides, generally chlorides are preferred because they are the most stable halides. Bromides are sometimes prepared, but owing to its higher activity and lower stability, generally these bromides are not preferred. While talking about this iodide, they are a little bit less reactive. That's why these iodines are generally not preferred. So, talking about this brief history about this Grignard reagent, the pioneering work in the discovery of this organomagnesium chemistry is done by one of the famous scientists that is called as Victor Grignard. And this Grignard reagent is, as I told before, is nothing but it is a combination of organic compound, that is R, that is alkyl group, aryl, or any vinyl group, that is attached with any metal, that is magnesium particularly, and there is a presence of any halide group, that is chloride, bromide, or iodide, and this whole combination, that is alkyl magnesium halide, is called as Grignard reagent, and the name itself is given in the fond memory of this invention. And this reagent is invented by this famous scientist, that is Victor Grignard, and due to his wonderful discovery, he has received Nobel Prize in 1912, and that's why the name itself is given as Grignard reagents. So, talking about this outline for the preparation of Grignard reagent, why this Grignard reagent is so popular? So, talking about the popularity of this Grignard reagent is the Grignard reagent is prepared by freshly dissolving and activating magnesium metal. The magnesium metal is activated by washing with concentrated HCl followed by water. And the magnesium metal is dried in oven and used whenever there is a need. But it is preferred that the freshly prepared magnesium or freshly activated magnesium metal is generally used in the preparation of this Grignard reagent. Next, the salon, that is also used freshly prepared, and the freshly distilled alkyl chloride, alkyl bromide is added to the reaction of the fly, that is containing activated magnesium dissolved in dry ether, and that is the reaction is kept at a very low temperature, that is at minus 10 degrees Celsius temperature, because the solvent that we are using in performing this reaction is ether, and the reaction is kept as it is under nitrogen or inert atmosphere, and then after 10 minutes the color of the reaction changes to colorless to brownish red, indicating the formation of Grignard reagent, which is directly used for performing any reaction. And whenever there is a complete formation of this Grignard reagent is there is there we can see that there are no trace amount of magnesium metal is present in the reaction flow. That is clearly indicating that your Grignard reagent is prepared and ready to use in the next reaction. So talking about the brief overview of reaction that is conducted by using this Grignard reagent in short is that if you take any Grignard reagent, if any electrophilic position is there, that may be aldehyde is there, that may be ketones are there, that may be esters are there, that may be epoxides are there, that may be any alkyl halides are there, or that may be some inorganic diatomic gases are there, that may be CO2, SO2, or even you can treat this Grignard reagent with carbon monoxide also. So there is very less probability where we can't use a Grignard reagent. So that means this Grignard reagent is highly versatile. That is very easy to prepare, very easy to use in any organic reaction, and at the same time, it has having a very higher scope of window to use this Grignard reagent in all the organic transformation. So talking about this Grignard reagent, why this Grignard reagent is so popular or so important? So talking about this Grignard reagent, it is one of the most important nucleophilic reagent, and in this, if we observe, generally any carbon atom that is present in organic chemistry possesses a positively charged carbon atom. That means it is highly electrophilic in nature. But if we consider this Grignard reagent, due to formation or linkage of this any metal with this organic compound, there occurs inversal of polarity. That means positively charged carbon atom is converted into negatively charged carbon atom. That means there is a clear cut inversal of flow polarity from electrophilic carbon atom to the electro negative carbon atom, and due to this one of the most important characteristics of this Grignard reagent, anything means any carbon atom in Grignard reagent can be used to act as a nucleophile rather than it is acting as a electrophilic center. So it is the importance of this Grignard reaction. Also, this Grignard reagent is having certain application. There are very few limitations are there, and that limitations are that whenever there is ineligible ketones are there, and when we add these Grignard reagents like the ketones, like ineligible ketones, as I told, like beta ketoesters, that may be alkynes that contains active hydrogen atom. These Grignard reagents fail to act as a Grignard reagent, and in such cases, instead of acting as a nucleophile, these Grignard reagent acts as a base, and by abstracting a proton, they will generate nucleophile. So this is one of the shorter limitation of this Grignard reagent. And finally, I would like to thank for your kind attention and patience for listening me carefully. Thank you very much, one and all.